today's video, we are going to input a simple data set first, then run a linear regression. The output has three parts. Our task number 1, replicate and explain part 1 of the regression output. Task number 2, replicate and explain part 2 of the regression result. Note number 1, for replication and explanation of part 3, see the first video. Note number 2, we are going to apply the following formulas later in the video. This is our expected final result. This is our starting point. Okay, so now we have x column and we have y column. Okay, so we are going to calculate according to the here we have the formula to calculate t, calculate e, calculate r. Okay, so actually we can visually just imagine. Okay, so this is start. Our benchmark is y bar, is mean of x. So we are going to calculate mean of y equal, we use average. Okay. So actually 20.8, so this is our mean. So actually the t you can think t is total distance. Total distance between yi from its mean. Okay, so this is t. The definition of t actually squared yi minus mean. Okay, summation is total summation. Accordingly, so this is y hat is estimate. So this is estimate from its mean. So this we use r. So correct definition is same thing as the summation of squared deviation from y hat from its mean. The leftover we call error, we call e. So actually e equals yi minus yi hat squared. Then we have a summation. Okay, so according to these three, okay, then we can calculate the t, e, and r. Okay, before we calculate y hat, we need alpha and beta. Then first we run a linear regression. We estimate alpha and beta. We click data, data analysis, regression. Then we enter y column. Then we enter x column. Okay. Because I check the label, I click here. So we output with the same spreadsheet. Okay, just click here, then click OK. Today's video we're trying to replicate. So this is I called part 1. So this is I called part 2. Remember for the previous email video, we explained we replicate part 3. Okay, so actually alpha is 7, beta is 3.833. Okay, so actually, so this is equals, alpha plus beta times x1. So this is first deviation, or sorry, it's not deviation, it's first y hat estimate. Okay, so equals alpha plus beta times x1. Before we copy paste, we have the fixed alpha and the beta. So we copy and paste. Okay, I'll copy and paste. Okay, the first one is equals, so this is y from its mean. So from 20.8, we hit F4 to lock the mean. then squared. So this is first squared deviation, because we logged the mean already. So just copy and paste. So then we sum. So this is summation. So actually, this is our t. This is our t value. Okay. The next one. So actually is y hat. So this is y hat minus mean. Okay, same mean. We hit F4, log it, then squared. Then we copy and paste. Then we calculate total summation. So actually, this is our R. Okay, so this is our R. The last one will be yi deviate from our estimated value squared. So actually, so this is our E value. So the total summation will be our E value. Okay. So actually, if you look at these three values, it's the same thing as the second part. Okay, I just highlight the second part. Okay, 139. So it's from regression. So its degree freedom is 1. So 20.833 is residual, and the summation of these two is 214.8. So let's just sum. Okay, so this one. Okay, the first one. So let's replicate the first part. So let's look at the R square. Okay, the R square according to this formula is R over T. So equals R over total. So R over total. Okay, so this is 90%. So we know R square represents percentage of result explained by our regression. The higher, the better. 90% is excellent result. Okay. So multiple R, so actually it is sine of B. So equals sine of our beta times SQRT R squared. So this is our formula. Okay, so this is equals, so this is sine. So actually we know beta is positive. Sine times SQRT. So R squared. So this is R squared. Then SIGA. Then we replicate our second result. Okay, and adjust R square. It is here we have the formula. Adjust R square equals 1 minus R square, n minus 1 divided n minus p minus 1. So actually, adjust R square, we factor in how many independent variables we used. Okay, if we had two models, one model with one dependent variable and the second model with, for example, 3 dependent variables, the R square of the second one is always higher than the first one because it has more independent variables. To factor in the number of independent variables, then we use adjusted R square. So adjust R square equals 1 minus R square. times n minus 1. So actually we know n is 5. So actually it's 5 minus 1. Divided by n minus p minus 1. We know n is 5 minus 1 and minus 1 again. So this is, we replicate the second result. Okay, so this is adjusted R squared. Again, when we compare different model with different independent variable, we should use adjusted R squared. Okay, the last one is of the part 1 is about standard error. Okay, so here is the formula. Okay, I'm going to copy and paste here. So actually, square root of e divided by n minus 1. So this is SQRT. And we know this is e, so 20.83. So divided by, so this is n minus 2. So then we replicate the last value of, so of course this is will be count, count. This is how many pair of observations. So this part we finish replicate part 1 of our simple linear regression. Now let's replicate the second part. So actually the last part of this regression. Okay, and from previous part we know we replicate 3 numbers. Okay, it's T, R, E. Actually is S sum of squared for the regression, for the residue, and for the total. Actually 3 number match this 3 number match this 3 number. Okay, so this is mean. Okay, so actually if we look at, it's simply total divided by degree of freedom. So this is 1. Of course we have the same value. Okay, the next one will be our this value divided by degree of freedom. So we replicate these 2 values. Okay, so actually like part 1 is look at how good our model in total, and part 2 is also look at goodness of fit of our total model. The part 3 is we look at individual variables. Okay, so let's look at F-test. So actually the null hypothesis is alpha equal 0 and beta equal 0. Because we only have 1 independent variable, so we only have 1 beta. So if we have 3 x's, then we have alpha equals 0, beta 1, beta 2, beta 3 are all equal 0. So alternative hypothesis is one of them is not 0. Okay, so this is alternative hypothesis. Okay, so first one, let's look at F values. Okay, F value is 20.9318. So actually F value equals, so this is mean of R divided by mean of E. So this is, we replicate this F statistics. Okay, this is F value. Okay. And so actually you can use a distance rule. We compare with F value with F critical value. If F value is higher than F critical value, we reject. So actually we compare this as F inverse the right tail. Assume we use 5%. So this is 5% alpha. Degree of freedom of regression. So this is 1. Then degree of regression of residue. So it's 1 and 3. Okay. Because 27 is higher than 10, so this is our decision rule. Okay. So this is if our estimate value is higher than critical value, we reject. Otherwise, we accept. Okay, so actually our decision is we reject null hypothesis. So actually based on this part 3, we know alpha, based on the t statistic, alpha and beta both are not 0. Okay, so this is we reject. So let's look at, so this is alpha. Okay, alpha is 5%. So let's look at, let's replicate this value. Okay, so actually significance f, so actually it's p-value. It's p-value. First one, so let's replicate. Okay, so this is f dist. So this is distribution, we use right tail. So our estimate is 27. Okay, degree of freedom 1 is 1. Degree of freedom 2 actually is 3. So we replicate this one again. So this is last value. So actually this is our p-value. So this is our p-value. So based on our decision rule, so this is we called shaded area rule. Shaded area. Okay. So basic idea is if a p-value is less than alpha, we reject. Otherwise, we accept. Then we have the same decision. So this is we reject and also reject. Okay. Okay. We finished replicate simple linear regression part 1 and part 2. Again, part 1 and part 2 is look at the goodness fit of the whole model, and part 3 is look at the significance level of individual parameter like alpha and beta. Thank you. After finishing watching this video, I hope you can try the following 2 hands-on tasks on your own. Challenging task number 1, generate 10 pairs of your own X and Y columns. Of course, you can have try 15 or 20 pairs. Run a linear regression, replicate all 3 parts of your output, like F statistics, test whether, and adjust R² and R². Challenging task number 2, download a dataset called safety. To get your data, there are 2 steps. The first step is get data ID. You use .search data. The input is safety. For this dataset, the dataset ID is 222. Step number 2, for PC user, then you can simply use .data to Excel 222. Then you launch Excel and paste it there. For the Mac user, then you use .search http CSV. The input is safety. After you hit the enter key, you'll see a link. Then you can manually download the dataset. The first several lines of the dataset is given. Run a linear regression and explain your result.